Welcome to the world of kinematics, where we explore the fascinating concept of motion and its mathematical description. Let's dive into the basic principles of kinematics, starting with displacement, velocity, and acceleration. The study of physics begins with mechanics. Mechanics is the branch of physics that focuses on the motion of objects and the forces that cause the motion to change. There are two parts to mechanics: kinematics and dynamics. Kinematics deals with the concepts that are needed to describe motion, without any reference to forces. Dynamics deals with the effect that forces have on motion. Kinematics is the science of describing the motion of objects using words, diagrams, graphs, and equations. The goal of kinematics is to develop mental models to describe the motion of real-world objects. We will learn to describe motion using 1. Words, 2. Diagrams, 3. Graphs, 4. Equations.
The motion of objects can be described by words. Even a person without a background in physics has a collection of words, which can be used to describe moving objects. For example, going faster, stopped, slowing down, speeding up, and turning provide a sufficient vocabulary for describing the motion of objects. In physics, we use these words as the language of kinematics. 1. Distance and displacement. 2. Speed and velocity. 3. Acceleration. These words, which are used to describe the motion of objects, can be divided into two categories. The quantity is either a vector or scalar. 1. Scalars are quantities which are described by a magnitude only. 2. Vectors are quantities which are described by both a magnitude and a direction.
Now, let's explore the fundamental equations used in kinematics, such as the equations for constant acceleration.
Displacement. Displacement refers to the distance moved in a particular direction. It is the object's overall change in position. It is a vector quantity. SI unit, meter, m. Other common units: kilometer, km, centimeter, cm. Distance versus displacement. You drive the path, and your odometer goes up. Your displacement is the shorter directed distance from start to stop.
Distance and displacement for some real-world applications. Let's solve the example. A student walks 4m east, 2m south, 4m west, and finally 2m north.
Solution. Total distance equals 12m. During the course of his motion, the total length of travel is 12m. Total displacement equals 0m. When he is finished walking, there is no change in his position. The 4m east is cancelled by the 4m west, and the 2m south is cancelled by the 2m north.
In conclusion, we've covered the main concepts of distance and displacement. Remember to practice and apply these principles to excel in AS level physics.